Today we're going to talk about the concept of limiting reagents, also called limiting reactants. First, we're going to review our steps for stoichiometry. The very first step that you do is to balance the chemical equation. Make sure that you have all the coefficients properly balanced, otherwise your answer will never be correct. After you balance the chemical equation, you need to convert any masses that you have into moles. This is our second step here. Our third step is to use the coefficients that you have in front of your reactants and products as your molar ratio. This will help you to determine the number of moles of the substance that you're looking for. We're going to be using a conversion factor, which we'll go into in a moment. After you've figured out the number of moles of the substance that you're looking for, you can convert that number of moles back into a mass, such as grams, or you can convert it into the number of molecules or number of atoms if it's an element. So what is the limiting reagent? You have to think of this in terms of chemical reactions. When you mix two reactants together, the chances that you have the exact proper amount of both reactants is almost zero. That's usually you have one of the reactants getting used up first, and the other reactant will have some left over. The reactant that runs out first is called the limiting reagent or the limiting reactant. The limiting reactant is not the reactant necessarily with the smaller mass, nor is it always the reactant with the fewest number of moles. It depends on the molar ratio. So how do you figure out which one is the limiting reactant? Take, for example, this equation. Do you recognize it? It is the combustion of methane. Methane, CH4, reacts with oxygen, O2, to produce CO2 and water vapor. Notice how we have all the states here. After you balance this equation, you end up with the coefficients of 2 in front of the oxygen and the water. So if you were to look at this in terms of molecules, you'll see that you have one molecule of CH4, two molecules of oxygen, one molecule of CO2 produced, and two molecules of water produced. So we say that this has a molar ratio of 1 to 2 to 1 to 2 for methane, oxygen, carbon dioxide, and water. What if I tell you that we are going to have 5 molecules of methane reacting with 12 molecules of oxygen? Well, you would tell me that the limiting reactant or the limiting reagent will be methane because only 10 molecules of oxygen will react with 5 molecules of methane. You see, the ratio is 1 to 2, so 5 to 10 is what we expect to react. Therefore, we'll have 2 molecules of oxygen left over. So how many molecules of carbon dioxide will be produced? 5, because of the ratio between methane and carbon dioxide. They both have a 1-to-1 ratio according to the balanced chemical equation. So if we have 5 molecules of methane, we should also have 5 molecules of carbon dioxide. We would predict that 10 molecules of water would be produced because the ratio between methane and water is 1 to 2. So if we have 5 molecules of methane, we should have 10 molecules of water. So instead of working in terms of molecules, we will be working in terms of moles using this exact same concept. So let's use this example to help us learn the steps for figuring out a limiting reagent question. You're given 8 grams of hydrogen gas and 24 grams of oxygen gas. The question is, how much water will be produced? This is a limiting reagent question because you have the masses of both reactants, meaning one of these two reactants will be used up first. So let's go through the steps of how to figure out which one is the limiting reactant. First, you're going to convert the mass of hydrogen into moles. Then you convert the mass of oxygen into moles. Then you'll find the limiting reagent. The fourth step is to use the limiting reagent to determine the moles of water using the molar ratio between the limiting reagent and the water. Finally, convert the moles of water to the mass, because that's what we're being asked to find, the mass of the water. All right, so to convert the mass of hydrogen into the moles of hydrogen, we're going to take mass over molar mass. 8 divided by 2.02 grams per mole is 3.96 moles. And this is the number of moles of hydrogen that we're starting off with. Now for oxygen, it's going to be 24 grams divided by 32.00 grams per mole. This works out to be 0.750 moles. So the first method of finding a limiting reagent is to use the 2 moles that we just found for our 2 reactants and try to figure out which one will produce the least amount of water. The reactant that produces the least amount of water is the limiting reactant. Here we see that the ratio between hydrogen and water is 2 to 2. So there's 3.96 moles of hydrogen. We're going to multiply it by 2 over 2, and that gives us our final answer of 3.96 moles. That's how many moles of water is produced if you have 3.96 moles of hydrogen. Now, oxygen. We found that we had 0.750 moles of oxygen, and we're going to multiply 2 over 1 times this 0.750. The reason why it's 2 over 1 is because there's a 2 in front of the water, and there's a 1 in front of the oxygen, even though you can't see it. This means that there's 2 times as many water molecules as there are oxygen molecules. So if we have 0.75 moles of oxygen, you should have double the amount of water, 1.50 moles. So which one is the limiting reagent? It's oxygen, because oxygen has only produced 1.50 moles of water. The smaller number of moles of water produced is the limiting reagent. In the alternate method, what you do is you take the number of moles of hydrogen and divide it by its coefficient, which is 2. 3.96 moles divided by 2 is 1.98 moles. You do the same for oxygen. 0.750 moles of oxygen divided by its coefficient of 1 gives you 0.750 moles. The smaller number is the limiting reagent. So now we have figured out the limiting reagent. It's going to be oxygen, and there are 0.750 moles of oxygen. We can continue doing our question as if it were a regular stoichiometry question. You use the limiting reagent to determine the number of moles of water. There are 0.750 moles of oxygen. You multiply it by the molar ratio of 2 over 1, and you get 1.50 moles of water. Then you convert the number of moles of water into mass. Mass is number of moles times molar mass. M equals N times MM. So 1.50 moles of water times the molar mass of water, 18.02 grams per mole, equals to 27.0 grams. There are 3 significant digits in our answer because there's 3 significant digits in our question. One of the things that people do that often are going to lead them to make a mistake is they don't use the proper molar mass. They might be using the molar mass of some of the other reactants instead of the molar mass of water. Another problem that people have when doing limiting reagent questions is they go back here and they use the wrong number to figure out the number of moles of water. They might say that there's 1.98 moles of water or 3.96 moles of water. You have to be very careful and figure out which one's the limiting reagent, oxygen, and use that number to determine the moles of water. It's 0.750 moles times 2 over 1 to give you 1.50 moles of water. Only when you've done all of the above can you get the correct answer for the number of grams of water produced from this reaction.